All right, let's get started. Hello, everyone, and welcome to Origin and Causes webinar titled Contractor Liability in Construction Claims. My name is George Costandi, and I'll be your moderator today. I want to welcome you all, and I hope you and your families are in good health and safety. I'm glad you all made it out. Thanks for joining us. I wanted to go through a few quick points with you first. So we're going to be doing a live Q&A at the end of the webinar. Please feel free to submit questions via the text box under the webinar screen. You see it's right here. We'll try to get to as many questions within the hour. If we don't get to your question, we promise to follow up with you after the fact and make sure that all your questions or comments or concerns are addressed. All the questions are going to be anonymously addressed unless you want a shout out. You just write your name and company name if you wish, and then you write in your question or comment, and we'll be sure to give you a shout out. Just a heads up, all information discussed in this webinar is for educational purposes only and should not be applied directly to the administration of any particular file or claim. Use what we're about to explain as a guide in your administration of claims or files or cases. And whenever you have some questions or anything that you would like to discuss with an expert, you give us a shout and we'll make sure that we go through all that with you. The webinar is being recorded and is going to be posted on our website, on LinkedIn, YouTube pages, so please feel free to pass them on to your colleagues in future meetings. We're going to be sending everyone a completion certificate and a follow-up email. Usually takes a few days to get those out to everyone, considering we have such a huge audience. As mentioned in our communications, accreditation is still pending in a couple of provinces, including Alberta. So please just be patient with us if you don't mind. It's a little bit of a longer process now, and we will advise you once it has been approved that you could actually input a course number and all that information into to hopefully get credit for this webinar retroactively. At the end of the webinar, when you close the GoToWebinar window, the program will prompt you to rank the speakers, the content, and any other feedback that you may have. And if you're experiencing any technical difficulties, please email the team webinar at origin-and-cause.com. And of course, please join the conversation on Twitter via #OCWebinar. All right, let's get started. So I'd like to introduce to you our speakers. The first speaker is Yasser Korany, who is a consulting forensic structural engineer with over 30 years of industry and academic experience and has conducted over 1,000 forensic investigations. His specialties include construction litigation, failure analysis, code reviews, building envelope investigations, and condition assessment of existing facilities. We also have Adam Lohonyai joining us today. He's a forensic structural engineer with 7 years of industry experience and has conducted over 400 investigations. His specialties are structural failure analysis, code reviews, condition assessment of existing facilities, farm buildings, and silo failures. We also have Kayla Kwinter joining us from Torkin Manes. She's a construction lawyer specializing in litigation. She's appeared before judges and masters of the Superior Court of Justice, construction lien masters, and the Ontario Court of Appeal. She's been elected to the Ontario Board Association Construction and Infrastructure Law Executive for the 2019-2020 term. Let's jump right into it, and the stage is yours, Yasser. Yasser, you're just on mute on your end.
Trying to unmute, yeah.
There you are.
There we go. All right. Thanks, George. Today we're going to have 3 speakers, so I am the first of 3. And the aim here is to share with you our experiences on cases where contractors found themselves involved in liability claims. What kind of scenarios? Cases like when you have projects with incomplete designs or details, where the contractors found themselves needing to come up with shooting arrangements that were not planned at the design stage, where contractors were involved in alterations, changes, and unfortunately, those changes resulted in some unintended consequences for the entire structure. An example of the unintended consequence of an alteration would be to cause the load to take a path resulting in loading non-structural members that were not really intended to carry any load. And we would share with you also what we learned from our investigations for all these cases, and hopefully we'd be able to make some recommendations. So there is a take-home message at the end. And we thought that it would be very useful to include a discussion on the legalities of the contractor liability, and that would be the concluding part delivered by Kayla. Next slide, please. So we're going to start with sharing with you a few case studies here. Next slide, please. Okay, here we go. The first case that we'd like to share with you is a livestock shelter. It is a recent construction, about 4 or 5 years old. The shelter is about 30 years wide. That's the dimension that you're looking at in the photograph, by 180 feet long. So it is a very long shelter. And unfortunately, the design for horizontal load, such as due to wind blowing on this structure, was not detailed enough on the drawings. And we're sharing with you here one of the part of the drawings where the designer, and I'm reading the part that's highlighted in yellow, decided that it would be appropriate to leave the bracing from the 6x6 posts to the trusses above to the contractor. So the note reads, bracing from each post to roof truss to be determined by contractor. And what happened that also the spacing between the trusses was left by the original designer to the truss supplier to decide. So we ended up with the spacing between trusses that resulted in no truss aligned right on top of the 6x6 posts. So the contractor was faced with a situation where there is no truss above the post, and those knee braces, the diagonal braces that you're looking at in the drawing, not sized for him, and no fastening information were provided. The solution to this challenge from the contractor's perspective was to simply say that, well, the truss doesn't line up, I can't install those. So he decided that these are not going to be installed. And as you could see from the photograph here on the left-hand side, the entire structure is swayed horizontally significantly. It was about the verge of collapse, and you could see significant temporary diagonal bracing trying to keep this structure in place. Next slide, please. The second example here is an industrial facility, an auto repair shop. The building was constructed of concrete block units. And during a windstorm, the entire roof lifted off the building as a whole, intact, and landed where you see on the photograph. And we were brought in to investigate this collapse. We looked around to other comparable properties, and we noted some damage to roof shingles, some damage to maybe one or two rafters, but nothing really compared to the extent of damage to this structure, which kind of prompted us to think about what is it about this structure that caused the entire roof to lift off. So by examining the top of the masonry walls, we found that the top plates, wood plates that are typically placed on top of the wall and the roof is tied to, fastened to, were not properly installed and tied to the masonry walls. And looking at the drawings, we found that no information was provided to the contractor as to how this top plate is ought to be secured to this hollow block masonry wall. So the contractor decided to block a few of these cores in the concrete block and bore grout and have anchor bolts to tie this plate down. Unfortunately, that was not adequate measure to tie the top plate and by association the roof down to the wall. And although it was a windstorm, the level of wind that structure experienced was still within the design load that this structure ought to have sustained. Next slide, please. This is the case of I call the leaning post. And what you're looking at on the left-hand side here is a photograph from an inside of an attached two-car garage. The brown stretch at the very top of the photograph that you're looking at represents the steel I-beam that's supporting the second floor wall above. And at the end of this beam, there is a leaning brown post that you're looking at and another upright black post. The upright black post is a temporary post that has been put in place to secure the beam after the brown one, the original one, has leaned and was kicked off from under the beam, as you can see on the photograph on the left-hand side. When we eventually took this post out, and I'm looking at the photograph to your right-hand side now, you could see the post laying on the garage concrete floor slab. You will notice immediately that a top plate is missing. And we also found that this post was not secured neither at the top nor at the bottom. So not tied to the steel beam, not tied to the foundation wall, was just pushed in. And we looked at the construction of the masonry wall that this steel beam supports. I'm looking at the photograph in the middle now, and you could tell immediately that this masonry wall is not blunt. It is bowed. And the reason is that there was misalignment between the location of the steel beam and the location of the masonry wall above. And the masonry trades person decided that the solution for that was to just try to curve this wall to make it meet the steel beam. So we ended up here with a condition where you have an eccentric load on this steel beam that's made worse by the curvature of the masonry wall. You have a steel beam that needed to be tied at both ends because of the load not being applied at the center of the wall, yet it wasn't tied. And you have a post that needed to be secured top and bottom that wasn't. So what happened over the years under the snow load, the cycles of loading and unloading of the roof, that this beam started to twist a little, kicking off the steel post underneath by a fraction of an inch, for example. But year over year, the cumulative action of loading and unloading this steel beam and continuing to twist and untwist resulted in that at a particular season, the steel post was completely kicked off from under the steel beam. Next slide, please. Here's a major industrial facility that consisted of 3 large pre-engineered steel buildings. And you notice, of course, right away on the right-hand side of the screen that a section of this building has collapsed. This section is the same one that you're looking at on the photograph to the left-hand side. 4 steel framed, 4 steel frames form this part of the building, and they collapse under wind. So what exactly caused this part of the building to collapse under construction, but not the other parts, for example? Well, we discovered that this part consisted of 5 steel frames, not 4. The 5th one would have been located at the beginning of the building, the farthest side that you don't see in the photograph on the left-hand side. But because of the some groundwater issues, the foundation for this 5th frame was not constructed. And according to the original design, the bracing for wind load was located at this frame, between this frame and the adjacent one, both vertically and horizontally at the roof level. Because this frame was not constructed due to the foundation issue, this bracing was not put in place. The contractor recognized the issue and tried to rectify this situation by installing cables. If you look carefully at the photograph to the left-hand side, you might see some white lines in the shape of X-shaped or cross-bracing between the beams and the columns, the beam and the columns of the frame, the farthest from the point of view the photograph was taken. The contractor did not seek any technical input from the engineer of record, from the pre-engineered building supplier, decided to rely in his own experience. During a storm, this bracing was not adequate, was not sufficient, and the structure collapsed. Next slide, please. We do have a video here actually of the few seconds leading up to this collapse, and it will be very interesting to take a look at this. What you're looking at to the right-hand side is the part of the structure that collapses, that's in the, kind of in the background, and you could see earth-moving equipment. You could see plumbers were doing work right next to the area where the building collapsed. A flatbed truck is parked there, white, and here you go. And the 4 frames just twisted, collapsed, and thankfully there was no fatalities in this incident, but there could have been. Next slide, please. As I mentioned in our introduction, that sometimes we could cause the load to take a path that was not intended in the design. So what we're looking at here is a living room ceiling and kitchen ceiling with some damage to the finishes, like cracks and gaps and some bowing. It is always difficult to take photographs of those conditions that you could look at and really see what's happening. On the right-hand side, This is a photograph taken from inside the attic space, and you will notice vertical wood members. These are prop studs that were used to keep the roof ridge in place temporarily during construction. These vertical members were not intended to remain. They were just there to facilitate the construction of the roof by keeping the ridge board in place. Contractor or the framer decided that there's no harm of leaving these on. These bear on top of the ceiling joists below. And what happened that the owners decided to remove a kitchen wall. So back to the photograph to your left-hand side, you're looking at living room, dinette area. Then to the farthest left, you could see the kitchen. There was a complete wall there that has been removed. And with the cycles of loading and unloading this roof with the heavier snow load in the recent years, the roof load, or some of it at least, has been transferred to the ceiling joists through those vertical members, the prop studs. And obviously, ceiling joists were not meant to carry snow load, so you could see cracking, bowing, and damage to finishes. Next slide, please. This is an interesting case where an elderly lady was awakened in the middle of the night with what felt to her as a bomb going off. What happened here is that the concrete floor slab in her basement cracked up all of a sudden in the middle of the night, and the enlargement in the middle of the close-up view that you're looking at in the middle of the slide is a typical crack. Again, if you examine this photograph carefully, you could see that the concrete has shifted, concrete in either side of the crack. There is a lifting or a shifting, vertical shifting along the side of the crack. What happened in this case that the sump pump failed. The area experienced a very volume of rain, high accumulation of water, high hydrostatic pressure around the property due to the accumulation of water that was high enough to cause the concrete floor slab to crack. Is that typical or normal? Well, properly constructed basement floor slabs wouldn't have cracked this way. Fortunately for us, during our examination, we found a cutout in one area of the basement floor slab. This cutout was created by the homeowner or her son, intended to be used to drain dehumidifier. So we were able to take some measurements of the thickness of the concrete, and you could see from the photograph to the right-hand side that the concrete was about only a couple of inches. That should have been about 4-inch thick concrete slab. Next slide, please. Here is an example where the contractor kind of steps outside of their area of trade and do the homeowner a favor. This is a very old brick chimney that extended beyond the roof line that's no longer used. So there is no need for it. When the time came to re-roof, the homeowner asked the roofer to cut the stand-off part of the chimney and just to close off the roof nicely. So the roofer proceeded with removing the top part up to the soffit level and finished the work. His work per se, there was nothing wrong with it. What happened later that this chimney collapsed into, or part of it collapsed into the attic space, causing some damage to the rooms on the second floor. Why the chimney collapsed? Well, when the chimney originally extended through the wood framing of the roof, it was supported horizontally at the top. Now that this part has been removed, there was no bracing, no horizontal bracing provided at the top of the chimney. You could tell from the photograph to the right-hand side, mortar is highly deteriorated. There was evidence of previous repair attempts, and it didn't take much of a horizontal load to give this chimney a push into the attic space. Next slide, please. To move from buildings to slightly more interesting topic, swimming pools, particularly fiberglass swimming pools, which require very careful and thoughtful installation for them to work properly. This is a very recent construction, again, about 2-3 years. The homeowner asked the company to open the pool for them. After the pool was opened, the homeowner discovers that a crack in the steps that's circled in yellow on the photograph to the left-hand side, as it is enlarged on the right-hand side. And of course, the question became, why this crack formed? Who's responsible for cracking this fiberglass shell? And as you know, once you have a crack in a fiberglass pool, the extent of the damage really escalates, and water leaked under the pool and caused damage to the hardscape and landscape, and the pool shifted. So it was a large loss. And what we found out from our investigation, that by looking at the configuration of this pool, you could see that there is a long bench along the long side of the pool. Then you have an entry-exit steps next to that. So you're creating a huge area, stepped area at the corner of the pool. That's really difficult to backfill and compact. And that's exactly what happened. It was difficult really to situate this pool and support it at this corner properly. So the backfill kind of settled down with the load from the water in the pool itself, exerted pressure on this corner, causing the pool to crack. Next slide, please. I will hand it over to my colleague Adam to go through the following examples with you.
Thank you, Yasser. So this here is a concrete block foundation wall that collapsed shortly after backfilling. The owner here had decided to install new perimeter drainage and waterproofing to prevent water from seeping into the basement. The problem was that the contractor decided to backfill using the clay earth that they had previously excavated instead of using a free draining gravel. And there had also been a lot of rain recently, so now that excavated clay is not only disturbed, but completely saturated with water. And then to make it even worse, the contractor was driving the Bobcat back and forth over this recent backfill in order to move materials between the front and rear yards. So that added a surcharge pressure on the wall. And adding all that up, it was just too much for this foundation wall to take, and it collapsed after one of those passes by the Bobcat. Damages here were somewhere in the low 6 figures range. Next slide, please. This was a semi-detached house foundation underpinning project that obviously went horribly wrong. On the left, you can see just some of the serious damage that occurred when the foundation wall collapsed. Huge cracks, the floors have dropped, there's a great big hole where a window used to be. On the right, that shows some of the temporary raker bracing that we designed as part of the rapid response to quickly stabilize the structure in order to prevent any collateral damage to the neighbor, and also to make it sufficiently safe to proceed with the investigation and then later demolished his house in a controlled manner. So there were a lot of problems with this particular underpinning project, but to try to boil it down, we had a situation where the designer was not a structural engineer by training. The procedure that the designer had prescribed for this project was not suitable for this particular job site because the soil was a loose sandy soil. And the contractor also was not really experienced with this particular procedure that was prescribed. And so both the designer and the contractor are navigating unfamiliar waters and perhaps not as familiar as they should have been with the inherent risks with what they were doing here. We also had shoring, the temporary shoring that was designed by the designer wasn't actually going to work. And when the contractor pointed that out, they kind of discussed something on site, and they came up with an improvised solution that turned out to be ineffective. So there were basically several red flags all along the way that all got missed right up to the day of the incident. And this house had to be completely, like this section of the house had to be demolished and rebuilt. And as I'm sure you can all imagine, an incident like this would easily run into the mid six figures range. Next slide, please. So this is another foundation underpinning failure. In this case, they were able to save the house, but nonetheless, it's still a very costly loss in the high five figures to low six figures type of range. So what had happened here was that the contractor was not familiar with underpinning at all, and had decided to proceed with this project without obtaining a permit or an engineered design. And that wall you see on the right was not installed until after the incident. This was that was the stabilization done by the emergency contractor. So they had excavated all along the bottom of the foundation wall with no bracing to prevent the foundation from sliding inward. And so basically the lateral pressure from the soil just pushed that wall inward, and it collapsed. In this case, the wall above surprisingly didn't collapse with it, but you know, this could have, if things had been different with the way this house had been built, this could have easily resulted in a total demolition situation as well. Next slide, please. Here we have a steel grain bin that has fallen over, and that steel ring you see embedded in the ground is what spreads out the loads from the legs of the bin into the ground below. Now, manufacturers of this type of bin don't design that ring so that you can put the bin just anywhere. You still need to prepare the site by providing a heavily compacted gravel base, or better yet, a concrete foundation. Of course, farmers will usually go with the gravel base because it's cheaper. In this case, the bin got installed without a proper base, and the result was that once this bin was full of wheat, the bearing pressure on that soil was just too much, and it failed and started sinking into the earth. So between the loss of the bin and the loss of the stored grain, we're in the high five figures range. Next slide, please. So this was a group of 4 bins that were installed on a raised steel platform. And the purpose of doing that is to allow trucks to drive under to receive a load. In this case, they were storing sand for the hydraulic fracturing process that's used in the oil and gas industry. And now these bins came crashing down shortly after they were installed. 3 of them had recently been filled, and one of them was still empty, waiting to be filled. We traced the source of the collapse back to some beam seat connections that were not properly checked by the designer. So at some early stage in the design, the connection arrangement was changed a little bit, and that minor change resulted in a very dramatic reduction in the strength of that connection. And in this case, the designer of the steel platform was also the steel fabricator. So we have basically a situation where the fabricator and the designer are the same person, or same party rather. On the right, at the bottom right, we see one of those column cap plates. So that's where the beam was sitting, and the cap plate you can see has been rounded off, just drastically bent under the weight of the beam. The top right there shows the beam, and you can see the stem of the eye, the vertical portion of the eye shape has folded in on itself. That's a failure mode we call web crippling. So there are a couple of seemingly minor changes that resulted in a very drastic reduction in capacity. And because that connection was never checked, it brought the whole structure down. This resulted in a very significant business interruption. Next slide, please. So here we have a masonry wall that collapsed during construction of, this was a warehouse building. The concrete block wall was to serve as a firewall, separating the warehouse space from the office space, and the rest of the building was steel construction. Now, the planned schedule was to build the firewall and then immediately proceed with erecting the steel so that the firewall would be braced by that steel. But when the steel fabricator got delayed, wasn't able to deliver at the on time, the general contractor should have gone back and said, well, what do we do with this masonry wall now? But instead, they kind of left the little bit of bracing that was in place during the construction of the wall, and they left that for several weeks. And one day, when the winds picked up, it blew the wall down. Luckily, at the time, there's no one on site, and so there were no injuries or fatalities. But that could have been different if this had been a busy job site. In this case, because it was very early, essentially all they had constructed were the foundations and the wall. The collateral damage was minimal, but they still had to obviously reconstruct this wall. Next slide, please. So this is another steel building that collapsed during construction. There are some similarities to the example that Yasser presented earlier. This was an industrial cold storage facility, and it was being built in 3 phases. Phase 1 was already up and operational. Phase 2, you can see a little bit of it in the top left of the photo. The steelwork was complete there, and the cladding was being put up. And then phase 3, the steel was being erected. We had about 25% of the steel in place. And then a windstorm came along and blew it down. Luckily, again, no fatalities. But you can see it could have been a lot worse. You can see some equipment that is buried under the debris there. So the problem here was, again, only one corner was properly braced with the permanent bracing, and the opposite corner was free to sway. And in this case, the erector had actually left it without any temporary bracing at all. So they left the job site one day, come back the next day, and the structure is down. Damages were in the low to mid 6 figures range here. And with an incident like this, of course, it's not just the cost to remove the debris and fabricate new steel. You've got all that collateral damage that needs to be repaired. All those columns that were bolted down to the concrete foundation piers, those anchor bolts have either been pulled out or they've broken the concrete out. So you have to repair all those foundation piers. And there's also the cost of delaying the delivery of the project to the owner. So the owner expected the construction to be completed by a certain date, and this is going to delay the project. Next slide, please. So this was a private riding arena on a farm, and the building had a noticeable lean of almost 2 degrees after a major windstorm just a few weeks after the building was finished. So this building had a few problems with the permanent wind bracing. And one of these braces is shown in that box on the photo. So it consists of 2x6 blocks cut to fit between the studs and arranged in a brace line. Now, the engineer's drawings had a few inconsistencies that made the bracing unclear. The drawings were actually drawn with the brace at 35 degrees, and if you had built it that way, you would have missed the doors. But all of the notes that specified the bracing said bracing at 45 degrees. So the contractor didn't seek out any clarification on this discrepancy. They just decided, we'll install the brace at 45 degrees and we'll locate the doors as shown on the drawings. So 2 of the braces were interrupted by doors, as you see in this photograph, which renders the brace totally useless. Also, because of the way that brace was detailed by the engineer, it's sensitive to workmanship issues, and so that was also a problem on this site. So other braces, we identified gaps between the blocks and the studs. So this brace only works properly if those bracing blocks are cut to fit tightly between the studs. If you have a gap, even a relatively small one, like 1/4 of an inch, suddenly that brace is much less effective than it's supposed to be. So between 2 braces not being effective because of the door openings, and then other braces not being effective because of small gaps, the wind bracing didn't work the way it was intended, and this building sustained serious damage in a windstorm. The cost to correct that lean and to brace it properly was pretty much the same as rebuilding the structure. So that's what they ended up doing, was demolishing, rebuilding, with total damages in the low 6 figures range. Next slide, please. So this was a tobacco barn that collapsed a few days after putting in the harvest. So the client here initially thought this was simply a case of the farmer putting too much crop into the building and overloading it. But we investigated and we found that the barn actually had a very serious instability problem. So the builder had actually left out more than half of the lateral braces that were needed to properly brace the rails that support the tobacco. So every time this barn was loaded, it was actually dangerously close to collapse. And obviously on this particular day it did. So damages were in the low 6 figures range. But one of the outcomes of the investigation was that now the insurer is aware that this is a problem with barns of similar design, and was able to warn the owner of this barn and other barns that, of similar vintage and by the same designer, that this potentially could be a problem. Next slide, please. So this was an older row house constructed around 1910 or so that had a small fire, and it affected the roof, and so part of the roof got rebuilt, which is what we're seeing part of here. And about a year or so after the fire, the owner notices they've got mold issues. And so this attic space is not, it's accessible by stairs. The owner uses it for storage. And originally that attic was an unvented roof space, and it was insulated with paper-faced batt insulation between the rafters. What the restoration contractor had decided to do was instead convert it to a vented attic similar to houses that are built today by insulating the attic floor and then installing one roof vent. So this created a condensation problem where none existed before. So, one roof vent is actually worse than no roof vent, because with vented roofs, you have to balance the ventilation between the upper and lower parts of the roof. So this building had never been designed with soffit vents or anything like that. So by putting a single roof vent, it actually created a significant problem. And keep in mind, this is an attic that's accessible, so you can't possibly seal it off properly from the space below. So really what they should have done is restored the building envelope the way it was, because it was performing adequately before. And basically the change is kind of a halfway measure to a proper vented roof, and just created a big problem. All those changes that the contractor implemented here had to be reversed in order to prevent the mold issue from returning. Next slide, please. So I want to leave off with some general lessons from some of these case studies. I think first is that temporary bracing and shoring during construction are the contractor's responsibility and are not to be taken lightly. Too often, temporary bracing is either omitted or it's ineffective. If you're dealing with a structure that falls down during construction, you're going to need to know what temporary bracing or supports did the contractor have in place and whether that bracing was engineered or verified. Contractors really should not be relying on this old attitude, well, I've always done it this way and I've never had a problem. That's a very dangerous attitude, and it's one we see commonly held until an incident occurs, like some of those case studies that we saw earlier. And then also remember that temporary bracing requirements evolve as the project progresses. So if the structure gets delayed or the job site has to shut down for a while, or the planned sequence of construction changes, this can all affect the temporary bracing requirements. So you're going to want to get a timeline of how construction progressed and what hiccups there were along the way. Another thing to keep in mind is that minor changes can have a very significant impact. So you want to know if and where the contractor deviated from the approved design, even if it seems like an insignificant difference. And of course, were those changes approved by the designer? Or did the designer make changes seeming, sort of late in the stage that might not have been properly assessed? Next slide, please. So sometimes as the project progresses, the contractor will discover site conditions that are different from what the designer had considered. And that could, of course, mean that some changes to the design are needed. So if you're going to want to find out if there were any unexpected site conditions, were those conditions discussed with the designer? Did the designer provide any sort of redesign, or did the contractor just sort of improvise some workarounds? Another thing to keep in mind is that oftentimes it's not the structural members, things like beams and columns, that are the problem. Often it's the connections that hold those parts together. So were any connection designs changed, whether that change was made by the designer or by the builder? There have been numerous case studies of structural collapse where it's stemming from just a single connection that was changed without properly evaluating that change. And then, of course, inspections are a very necessary quality control process. Was the building inspected by the designer or just the local building department? Has the builder been calling in for those inspections on a regular basis? Are they keeping on top of inspections? Or is it kind of a situation where the designer shows up randomly and he has to catch the builder off guard? And if an incident occurs, you're going to want to be able to obtain copies of all those inspection reports and photos to get a picture of where things were at the time of the incident. And with that, I will hand things off to Kayla.
Thanks a lot, Adam. As George said earlier, my name is Kayla Kwinter. I'm a construction lawyer at Torkin Manes. And now that we've heard Adam and Yasser take us through a number of case studies, we're just going to talk very briefly about the liability framework for liability arising out of construction defects. So we can go to the next slide. So there are really two sources of liability for construction defects. The first is breach of contract, and the second is negligence. Today's focus is going to largely be on negligence. I just wanted to make brief comments about the distinction between claims arising out of breach of contract and claims arising out of negligence for construction defects. The primary differences are, one, the scope of who you can be liable to for construction defects arising out of breach of contract or negligence. If the liability is breach of contract, then you can only be held liable to the other party or parties to the contract. So if a general contractor makes a mistake, their liability is going to really be to the owner of the project if we're talking about breach of contract. With negligence, as we'll see, the scope of people that you may potentially be liable to is a lot broader. The other big difference is that typically insurance policies do not cover claims for breach of contract, whereas they may cover claims for negligence. For any adjusters or other insurance professionals who are tuned in, remember that sometimes a claim will be pleaded in terms of both breach of contract and negligence, and in that case, an insurer may defend under a reservation of rights. So they might say, we will defend this claim, but we reserve our rights to later take the position that this claim does not fall within coverage if it turns out that this is really a breach of contract claim. The last difference between the two, which turns out to not be a very big difference at all, is that liability for breach of contract has to be pegged to a breach of a contractual provision, and liability for negligence doesn't. And we're going to talk a lot more about where the liability comes from in negligence. But of course, most construction contracts will require explicitly, if not implicitly, but typically even explicitly, that the contractor perform its work to, the reasonable standards of a skilled contractor or trade. And so the liability turns out to be very similar under both sources. Next slide. So as I said, the first question in a liability analysis for negligence is, do I owe this person a duty of care? Is this a person to whom I can be liable for a construction defect? And as I said, the range of people to whom you can be liable for arising out of negligence is actually quite broad when it comes to construction defects. So the test that the courts have set out is anyone that is in a relationship of sufficient proximity to the contractor that it is reasonably foreseeable that such a person could suffer harm arising out of lack of care by the contractor. This could be the owner of the property, obviously. If it's a tradesperson, it could be the general contractor that suffers damages and to whom the tradesperson might be liable, other contractors working on the site, and neighboring landowners, for instance. So one case that Yasser and I worked on together a couple of years ago provides an interesting example here. And the case didn't go to trial, so I can't tell you what happened. I can only tell you what the positions were that the parties took. But in that case, there was a municipality that was conducting some sidewalk reconstruction. And when the contractor went to remove the existing sidewalk, the contractor pulled the sidewalk out away from the building and learned at that point that the building that was neighboring the sidewalk was actually bearing down on the sidewalk, which was pretty unusual. And so when the sidewalk was pulled away, it was actually pulled out from under the building, which caused some of the brick facade to crumble. And then the following day, the rest of the wall collapsed. So in that case, the contractor who was doing the road sidewalk construction was obviously contracted by the municipality because it was a sidewalk reconstruction project, but they were sued by the owner of the property that abutted the sidewalk because their negligence or alleged negligence caused damage to the neighboring property owner. Next slide. So the next question, if you establish that this is a person to whom you owe a duty of care and to whom you can be liable, is whether or not you've breached the requisite standard of care. And the standard of care is a moving target. It changes based on the nature of the claim being advanced. But in a construction defect context, the standard of care is always going to be judged by what a reasonable person would have done in the circumstances. In a construction defect context, you're going to be concerned with a reasonable person with the same skill, knowledge, and expertise of the contractor who made the mistake. So relevant considerations are going to include building code regulations, other governing laws, industry standards, and the experience of the contractor. You can be pretty sure that if a contractor fails to meet building code requirements or other governing laws, the contractor is probably going to be found to have breached the standard of care. Likewise with industry standards, If there's evidence that a particular standard is typical within the industry and typically well known within the industry, and the contractor fails to comply with that standard, they will also probably be found to have breached the standard of care. Next slide. So the next question is causation. And the question here is, okay, there was a construction defect and the contractor maybe fell below the standard that was expected of them, but did they actually cause the loss that occurred? And the test that's typically employed by the courts is a but-for test. The question the court asks is, would the loss have occurred but for the contractor's negligence? So another way of saying this might be, if the contractor hadn't made this mistake, if this defect hadn't occurred, would we still have seen this loss? And sometimes the answer could surprise you. So for instance, in the case, the sidewalk case that Yasser and I worked on a few years ago that I mentioned earlier, it looked pretty cut and dry when you looked temporally at what happened. So the sidewalk was pulled away from the building facade crumbled, and then the building wall collapsed. And that all looks pretty causally related. And of course, the building owner took the position that it was causally related. But some issues came up throughout the course of the litigation. And so it turned out, for instance, that there was a deflection in the wall, and the wall, it was alleged, was not structurally stable to begin with. Some foundation issues were discovered. And so the contractor took the position, of course, that this wall was probably going to either collapse on its own or need to be taken down, regardless of the sidewalk issue. And of course, as I said, the matter never went to trial, so we don't have a decision on the issue, but I think it provides an interesting perspective on the causation issue of something that looks like it probably was caused by the construction defect, but actually there are some arguments to suggest that actually maybe it wasn't, the causation didn't quite work that way. Next slide. So the next and sort of final stage of a negligence analysis is the question of remoteness. So not only do you have to be able to show that the contractor's liability caused the loss, but the type of loss has to have been one that was reasonably foreseeable as arising out of the contractor's negligence. So that is to say that the contractor has to be able to say from the outset, it is reasonably foreseeable that if I make this mistake, this kind of loss could arise. So in the sidewalk example, it may be unusual for a building to be bearing down on a sidewalk, but it's not completely unheard of. And arguably, a contractor, it's reasonably foreseeable to a contractor that if a building is bearing down on the sidewalk and the sidewalk is removed from under the building without due care being taken, it could cause damage to that building. That's arguably not a remote loss. Another example, on the other hand, which is, I'll give a silly example. Suppose we have a shower that's not caulked properly and is leaking, and the homeowner thinks, oh well, I can probably fix this. I just need to go over to the hardware store and pick up some caulking. And it's a nice day, so the contractor decides the homeowner decides he's going to walk his dog to the hardware store, and on the way to the hardware store, the dog gets hit by a car. The dog's fine, but the homeowner has a very high veterinary bill. And the homeowner says, well, but for the leaking shower, I wouldn't have been walking my dog to the hardware store, my dog wouldn't have gotten hit by the car, and I wouldn't have this veterinary bill. That's a loss that I would argue is probably remote and probably not recoverable as against the contractor for the construction defect. Next slide. So once you've established that there was a construction defect, that it fell below the standard of care, that you can be liable to this person, the last question really is, what damages is a person who is suing for a construction defect entitled to recover? And the general answer is any of the damages that are incurred as a result of the construction defect, apart from any that are too remote, like the veterinary bill example. So this will usually include the cost of correcting the defective work, the cost of resolving any other damage that arose to the property out of the defective work, and any losses suffered as a result of interruption to ordinary business operations. And we heard about all of those different kinds of damages when Yasser and Adam took us through the case studies earlier. Most of you who are working in the insurance industry will know that insurance policies cover most of those when they do cover negligence arising from, construction defects arising from negligence. So, subject to any questions that anyone has, that's what I had to say.
Awesome. Thank you very much, Kayla. Appreciate it. So this is the chance for you guys to submit your questions. If you just go to the GoToWebinar kind of portal, you could see that there's a little tab that says questions. So please do so, and we'll get through them. So I'll just jump right into it. First question says, so they just cut through the brace. I believe that question was for Adam on the leaning riding arena.
Well, actually, they didn't cut through the brace because they constructed the wall with the door opening, and the brace is a sequence of blocks that goes between the studs along a line, and that line just happens to intersect the door opening, and obviously you can't put any of these blocks through that door opening, so there's no brace. Effectively, there's no brace on that wall there. And then the other problem is that because the blocks are supposed to be cut between the studs, if you cut one of those blocks too short, now there's a gap, and that brace doesn't work the way it's supposed to.
Great, thank you. Next question. Can Kayla please provide some relevant case law regarding construction liability, specifically surrounding the responsibility of general contractor for subtrades?
So I'm not sure. I think I understand the question, and I'll answer based on my understanding. And if the person who asked the question wants to clarify at the end of my answer, please feel free to do so. So really, when you have an owner of a property, they contract with the general contractor. The general contractor contracts with the subcontractors. So when we talked earlier about the distinction between breach of contract and negligence, the owner of the property doesn't have any contractual relationship with the subcontractors. So the owner doesn't have a claim arising out of breach of contract against any of the subcontractors. The owner would have a claim arising out of breach of contract for the general contractor, and the general contractor would be responsible to the owner for any negligence or any construction defects that occurred by the hands of its subcontractors. So the general contractor, strictly speaking, is liable to the owner for the actions of any of its subcontractors. Now, of course, the general contractor can in turn sue the subcontractors and claim indemnity from them. That being said, on the negligence analysis, the owner may well have a claim directly against subcontractors, again, arising out of negligence. But in a typical construction pyramid, you would see the owner suing the general contractor, who has a direct obligation to the owner, and the general contractor turning around and suing its subcontractors.
Great, thank you. We have went over our time, guys, and I'm sorry. It was due to the fact that we had some technical issues on the front end. We're gonna stay on and answer questions for the next 4 minutes, and then we will drop off and answer any of your questions that you've submitted. So if you have any questions that you want answered, please submit them now, and we'll get through them hopefully either in session or post session. Next question: can you recover engineering fees or origin fees required to determine that an error occurred? Is that something?
Probably a question for me.
Yeah,
So
go
if
for it.
Adam or Yasser has thoughts, I welcome their thoughts. But from a legal perspective, the answer is probably yes. Usually those costs may be undertaken by the property owner in investigating the issue in the first place, in which case the costs would probably just be a damage that flowed from the construction defect. The alternative that you would see, and that certainly Yasser and Adam see a lot, is that they may be retained by the insurance adjuster or by the lawyer as a construction litigation expert. And in that case, the costs would probably be a litigation disbursement, which are still claimable on a full indemnity basis. So you can recover 100% of the costs that you've spent on that. It's just a little bit of a difference about how they're claimed in a lawsuit. But fundamentally, the answer is yes.
Okay, great. Thank you. Next question. The bracing example, would these errors not have been picked up by the building inspector and some responsibility would be on them as well?
That's actually a good point. So in this case, the inspector for the county missed those problems, as well as the engineer. In this case, this was actually inspected by the engineer, and they provided a letter saying that all the work is completed in general conformity with the design. So in this case, actually, it did quite a bit of the liability went back to the engineer because of that letter. But yeah, even though you have that letter, the contractor is still required to comply with the building code, and so sometimes it becomes a back and forth. Well, even though I said it was generally conforming with the design, you're still supposed to build it the way my drawing said, and you didn't, right? So that's something that gets more into the litigation side. But yeah, it's certainly something that should not have been missed.
Great, thank you. One more question, and then we will take all of your questions offline. So if a contractor works on his own home and there is a construction defect that causes a loss, what policy covers a loss, the homeowner's policy or the contractor's policy? Kayla? Kayla, did we lose you?
I don't think that's covered, George. There is no policy would cover that.
Well, okay. So I think that will, George, I am unmuted. Can you hear me? No, I can't, Kayla. She just sent a message. Let me just try to find her, then we will, Kayla. Kayla, you're unmuted. Can you hear us?
Can you hear me?
Yes.
Oh, perfect.
That last question, if a contractor does
Yeah.
work.
I mean, Yasser's probably right. I was going to say that it would really depend on the specific wording of the policies, but it's unlikely to be covered. The only scenario in which I can see it being covered is if your negligence, if your homeowner's policy covers something, but it's a tough one. I can't see an insurance policy covering that.
And what would be the relevant exclusion?
As I said, it depends on the policy, but I think in some policies that's probably not even going to come within coverage in the first place. So, homeowner policies usually have an exclusion that says that if a contractor is working on your home and they make a mistake, homeowner policies usually don't cover the cost of making good the contractor's error. Sometimes they will cover consequential damage that arises from the error, but usually they won't cover remedying the error itself. And so
Yes, but the
I would
resulting
think
damages.
exactly. So I would think that if you did the work yourself, you'd probably be caught by that same exclusion. But that's the first thing that comes to mind. I think there are probably a number of other coverage issues and exclusions that would arise as well.
Okay, cool. Hey guys, thank you so much for joining us and staying on. We are over time, and we really appreciate you hanging out and listening to the questions. We have a pile more questions that have been asked and submitted, so we will be following up with you, and we will be sending you completion certificates probably within the next 4 or 5 business days. So please just look out for those. Once we get verification of accreditation in the outstanding provinces, we'll send you guys a quick email just letting you know if you want to submit that hour into the system. You can do so at that time. Thank you again. Also, there is a feedback kind of notification that'll pop up on your screen when you close this window. We'd really appreciate if you give us your thoughts on how things went and any other feedback that you have. Thank you guys, and please stay safe out there, and hope that you could join us for the next one. Have a great day.